Okay, cool. Well, first, thanks for those who are coming. So yeah, so today we're gonna do like a hands-on workshop over 2 parts. And the title of the workshop are how we will transit from an ERC20 and ERC721 code base to LSP7 and 8. So the idea is that I will showcase how you can refactor a Solidity contract, starting from like an ERC20 boilerplate, and you will see how easy it is actually to just change the code to make it like the LUKSO token standard. And the reason of the title of like breaking up with ERC20 and ERC721 is because the token standard on LUKSO have much better features for safety, and we will go through them in detail in the next part. So yeah, so a bit of introduction about myself. So my name is Jean, and I lead the smart contract team at LUKSO, and I'm also the author of All About Solidity article series, and yeah, and I'm really passionate about smart contract technology, and I've been coding in Solidity for the last now almost 3 years and a half, 4 years, and yeah, and I really like sharing my learning and like all the features of a programming language. So yeah, this is what I do during the day. I work on the LSP smart contract repo, and at night I work on the Solidity article series. So yeah, so as I said, we're going to start with a sample ERC20 token. So do you know, guys, the OpenZeppelin wizard, the tool? Have you ever seen that? Yeah. So we're going to use that. The only thing is that we are a bit limited with the wizard, like give you the feature from 5.0, but we haven't migrated yet the code base to OpenZeppelin 5. So it's just one constructor argument that is adjusted. But yeah, we will use just the pre-sample code from OpenZeppelin, and we're going to refactor it. And yeah, first part of this workshop, it's going to be Solidity, and yeah, it's an interactive workshop, so any question during the course of the workshop, feel free to ask or for any help or for debugging, and I'm happy to jump in and answer. So yeah, so as I was saying, to get set up, I've kind of prepared like a repo. So if you go to my profile on GitHub, if you go here, so if you type github.com/cj42, you click on the repository, and you will see the LUKSO playground. There is like a fork. Did you find it? Yeah. And you should see you should click on the branch Migrate ERC to LSPs. All good? Yeah. And if you click on here, open in GitPod, it's going to ask you to create like a new workspace. And basically the idea is that you have a whole thing set up. You don't have to clone the repo or install the dependencies, and it's just a pre-build so that you can code on the browser. So yeah, I'm gonna do it in VS Code, but yeah, it's just.
Sean, does this give you a runtime environment?
Huh?
It gives you like a runtime environment you wrote in.
Yeah, you can code in the compile. Yeah. Yeah. So like is it running? Oh, you have to create. Yeah. Okay. Yeah, let me know if you have any issue. All good? Yep. Is it loading? Yep. Okay, nice. Perfect. Yeah, GitPod is good for setting up everything. You just run it, it's ready. So like, yeah, you can configure it to run like So I just made it so that it runs npm install, npm build. You have all the artifacts that are ready. Yeah, I mean, you can code it VS Code, but this is just for like, you can clone the repo if you want on your end, but it was just to get you started quickly. You have any, no errors? No? Okay, nice. Okay, cool. Yeah, let's get started then. So, so you don't need that for this first part. It will be for the next one. And I mean, we are not so many people, so I put a pad in case if you have any question or you need some test leaks. But I will ask you directly. It's okay. Okay, so let's get started. So we're gonna do the refactoring of the code base from ERC20 to LSP7. So the way we're gonna do it, we're gonna go to OpenZeppelin wizard, and we're gonna say, okay, so we're gonna select we're gonna name our token, let's say EcoCoin, ECN, and we're gonna say we're gonna pre-mint 10,000 token, and the parameter we will say you can mint it and you can burn it, and it's just an honorable token contract. So once you're done with that, you can copy the code in the clipboard. I'm just going to use VS Code for me, not GitPod, because it's a bit softer, easier for me. And yeah, we will go into. So we're going to create a Solidity file in the GitPod, okay? And we're going to paste the code that we got from the wizard. So here here the only difference is that we are using ERC20, so the version 4 from OpenZeppelin. So like there is no ownable constructor, and we just need to do transfer ownership to the initial owner. So this is just the current workaround at the moment with like version 4.3. Okay, so just a bit of an overview. Like what we do here, we're just deploying an ERC20 token that you can burn. We set as the owner of the contract the initial owner as a parameter, and we pre-mint 10,000 token for the initial owner. So now what we're going to do is that we're going to refactor that with to use LSP7. So the first step for refactoring is actually I will make it a full screen. And I will switch like that. Yeah. So we have created the token. We copy paste the contract. Sorry, I went a bit too far. Yeah, so we pre-minted 10,000 token. We picked mintable, burnable, copied the code. Is it all good so far? Yeah. Okay. So the first step for refactoring from ERC20 to LSP7 is that we're going to use the LSP7 contract package. So in LUKSO we have like different package for the token and NFT. So that's our first step. So in order to import the contract, so we have them installed already. So we're going to do import LSP7 digital asset from, and the package is from the LUKSO organization, LSP7-contract /contract LSP7 digital asset. That's all. Okay. So this is going to be our modules here. So we're not going to use ERC20. We're going to use LSP7. Okay, so from ERC20 to LSP7. And then we're going to import LSP7 burnable, and same from LUKSO LSP7-contract/contract, and we have the same folder structures as OpenZeppelin. We have the extension folder, and then we will do LSP7 burnable. So, and instead of ERC20 burnable, we will do LSP7 burnable, and we don't need ownable because it's by default within the inheritance. So what we're going to do is that we don't need transfer ownership. Obviously here we get errors because we don't have ERC20 anymore. So we can remove that. And yeah, and here, so like, yeah, the best way to go with Solidity is always to look at the error of the compiler. So the compiler always will teach you everything that you're doing wrong and what you have to do. So here it says, no argument passed to the base constructor. Specify the argument or mark echo cone as abstract, meaning that you cannot deploy it. So basically what it means is that we need to pass the argument to the LSP7 deployment argument. So, so we inherited this contract, and this is what we need to specify. So for an LSP7 token, it's the same thing as ERC20, except that there will be 2 extra parameters. So I'm just going to write them here. So we're going to do LSP7 digital asset. Okay. So we're going to do string memory, the token name, string memory, the token symbol. Then we're going to do address. I mean, we don't even need to. We're going to do it like that here. Address initial owner. And here we're going to have to specify 2 extra parameters. We're going to have to specify the token type. So this is the 2 new parameters with LSP7. So LSP7, it's the same argument as ERC20 with 2 extra things. We have to say the type of token we are creating and if the token is divisible or not. So that's the 2 new things. What's the token type? The token type, it's going to tell you, because the token standard of LUKSO, they are quite flexible and extensive, is to describe how the contract, what kind of asset it represents. So 0 is to say that this is a fungible token, meaning that each token has the same value as of a token. A non-fungible one, meaning that each token are they technically have the same metadata, but they are represented uniquely. Or the third one is a collection, meaning that each token is actually unique. So like, yeah, it's either they are mutually interchangeable or not, or they are representing a whole collection. So the way to say it is that here we're going to say it's a token, so it's going to be 0, and then the next parameters is to say if you can divide the token or not. So meaning like in basic term, if I can give you if one token can be divided in multiple smaller units, so like you know like any fiat currency, like you can divide $1 in 100 cents, or if it's non-divisible, it's like a full unit that you transfer. So here we're just going to do it as it's non-divisible is false to make it standard. Yeah, we actually don't need that. Did I do it again? I mean, we could just like write directly. So we will say echo coin ECN pass the parameter here. Yeah, we will see that in a minute. So like to better illustrate what we do is that we also have in the smart contract package, we have like constants. So like you can import this constant, like rather to memorize what the number, so rather than memorizing what the number means here, you can just use directly the constant for the package. So you can just say import, so I think it's, let me see, LUKSO LSP4 contract. Yeah, you see within the license you have everything here so I think it's LSP4. So you see, like, yeah, you have LSP4 token type token. So instead of saying 0, we want to write clean code. It is readable. We just say token type token. All good for now? Yeah? Nice. Yeah. Any question? Like, feel free to interrupt. It's like just like even for the high level thing, or please don't hesitate. Okay, so now step number 2. What do we need to do? Well, we need to. So we say it's a divisible token. And now we need to change the logic of a function. So yeah, always the same. Like what I like when writing Solidity is that you just follow, like really the compiler, it tells you everything. Like if people get scared when they see like it doesn't compile, you don't have to, it's because basically the compiler will tell you exactly what's missing. So like here it says wrong argument count for function call, 2 argument given but expected 4. So what does that mean? That means that in ERC20, when you mint, you have 2 parameters that you have to give. You have to give the recipient, who you are minting for, and the amount. So like here, what this means is that you are minting 10,000 tokens, but because they are like divisible, you have to multiply with a number of decimal, so 10 to the power of 18. Like 1 ether, it's 10 to the power of 18 way. So it's the same thing here. So what does that mean? That means that here, the min function in LSP7, it takes 4 parameters. So if we, a good way to debug the code is that if you hover over LSP7, maybe you might have like this small window that will appear, and then you can really look into the actual code base inside. So if you scroll down, or if you search for mint, I think it will be actually in this one. If you search for mint, you will see that there are 4 parameters here. So same, the 2, the amount, and then there is 2 extra parameters which are force and which are data. So the force parameter means force parameter, it means the following. Like from a non-technical perspective, is that in the LUKSO ecosystem, what we say is that we have to ensure that whoever we are transferring the token to, he can handle them. He can hold them, and he can retransfer them. Because you can send like to a wrong address, for instance. You can send to an externally owned account where the private key might have been lost. And the way we do that is that in LUKSO we tend to emphasize transferring assets to a smart contract like Universal Profile that can handle these assets. And basically the way a LUKSO contract can handle assets is by implementing what we call a universal receiver. And meaning that they can then customize the way they hold the assets. Like if they want to accept them, or if they want to reject them. And LSP7 and 8 basically is by default aware of that. It has to specify if he wants to safely transfer an asset to a recipient that implements LSP1 or explicitly force the transfer and say, okay, the recipient might not be able to hold the asset. And this is what the codes, what we try to explain in the comments here. We say like a Boolean describe if transferred to a recipient address that does not support LSP1 is allowed or not. Does that make sense here in the, yeah? Any question? Feel free to jump in. Hi.
It's a talk on like moving away from the ERC20 and 721
Yeah.
LSPs.
It's a workshop, but if you have question more of a high level, you can.
It's good from the NFT standard.
Yeah.
Yeah, explaining how like Ethereum standards, you know, very different from LUKSO standards.
I'm done my day outside.
Yeah.
Okay. Okay, so yeah, and then we have a second parameter, which is, so yeah, this is how it works for like the fourth parameter. So here you can see, so like the flow is as follows. Let's say here, so let's say I am Alice, like Alice and Bob, the traditional way in cryptography we describe. So Alice, talk with the token contract and say, I'm going to send 10, I don't know, like 10 echo coin to Bob. And what the contract does is that it's going to register for the sender, it's going to decrease the balance of the sender, increase the balance of the recipient, and then it's going to say, first notify the sender that some token has been sent, so like if there is an operator that interacting, and notify the recipient, like Bob, that he received some new token. So this way the recipient, through its interface, he's always aware that he's receiving new token. So this is the flow, basically, of that. This is very LUKSO specific, and we will see in the part 2, it's what enables to receive tokens and see them in your wallet without that you have to add them. Because like in MetaMask right now, if I send you a token, if you give me your address and I send you a token, unless I tell you I've sent you token, you will never know. You will have to import the address of the token contract in your MetaMask wallet. And here with LUKSO, we don't need that. It's always automatically registered.
So it's like automatically added to a wallet?
Yeah, so like here, for instance, I will show you. Like, I will switch to the, I will show you actually live.
Yes. The brave man.
Yeah, yeah.
That's
Oh yeah.
That's the slide I like.
Oh really? Jeez.
So let's say if I do, I will switch to testnet. So this is my universal profile. Yeah, I mean, I could show my wallet. So like, yeah, here the NFCs, for instance, that I hold in my wallet, they are registered automatically. But like when you, I want to do actual transaction. I think it looks nice. But the internet is not. You were saying in ERC725, like yeah, in ERC725 inspect, we could show it actually. So like my assets, they are registered, they're basically registered here. This is the list of assets that I own. So every time I receive a new asset, if you send me new token, they're going to be registered in this list. Yeah.
What about the spam protection or something like that?
So the spam protection, you can set up your LSP1, your universal receiver contract. So this contract here, so the tech standards. So like this is the whole flow. Basically, so this is what I was showing. Like it notifies the sender and the recipient, and you have a contract linked to your profile that handles that. So like you could have a contract that you can configure to say if the token you are receiving is part of this list of spam token, reject them automatically.
So you have sort of like some whitelist and blacklist.
You could set up, you could really configure it to do that, yeah.
Okay.
Yeah. Or you could even configure it to say, I don't want to receive NFTs, I just want my profile to receive just tokens. Or like, yeah.
So it's really just a hook, so you could put any hook there
Yeah,
to run at all.
exactly.
Whenever you receive the token. So it's entirely up to you, it's just a hook. Some code will
Yeah.
run whenever you receive a token. You can just put whatever code there you want.
But then this, let's say, NFT or token wouldn't be just displayed in my wallet, or it wouldn't even be there, and like the blockchain to reject transaction.
They will not even be there. There will be the transaction will always fail because you will revert. You will make the whole transaction revert basically. I think it's because I have MetaMask probably installed. Yeah, I want to try to show quickly on the diap because I think it's Web3 on board. Okay, yeah, I cannot switch to network. I don't know why, but yeah. Anyway, I will show you later. Okay, yeah. So yeah, then let's refactor. So we're gonna say I'm gonna save 2. We're gonna, as usual, we're gonna mint for the initial owner. The amount is gonna be 10,000 token. What I like to do is I like put underscore so that you can read the 1,000 separator. We're gonna say true to say false, and then the data, which is the last parameter, which I didn't cover actually. The data is basically by default in the functionality of LSP7 is that you can say, you can pass any data that you want alongside the call. So like, this is useful if you say, if you want to use that as like a form of receipt, you know, like writing information like as a receipt, or if you want to, that the recipient receive data that he can then process. Like for instance, that's useful like in DeFi, like for doing swaps. Like if there is like, you can specify things like minimum slippage or like any other configuration. So like the recipient, which is like the router, can then take this parameter, unpack them, and then process and carry on its own. So yeah, this is like a nice, useful thing. So like we could do some. Yeah, we could do some funny thing actually. We could say things like bytes minting some tokens, and we could say fire, and we could say, and because we are writing Unicode. So you see, like it's always like the same. Solidity, invalid character in string. If you are trying to use Unicode, use Unicode. Blah, blah. So like it's always the same. Solidity compiler tells you what to do. So yeah. Anyway, I'm getting distracted. Okay, so yeah, so like basically this is how we refactored the min function and And we can do the same here. We can do force, and we can here not specify any data, or we can add it as a parameter data, and we pass it here. Okay, yeah, and because it's a Solidity workshop, I always like to go the extra mile, showing some additional tips and tricks. Nice thing that I like in Solidity is what I call name parameter. So for someone who is new to the code base and doesn't know, it might not necessarily know what these 4 parameters are. So what I like to do is to do the following. You write a pair of curly braces, and you look at the name of a parameter, and you say to, so you are minting to the initial owner. The amount will be 10,000 times 10 to the power of 18 is the decimal. Force will say true. Can add a nice little comment because we are professional and we want code clarity. We can say allowing to send to EOA as well. And then data, we will say this. So yeah, we have a nice, clean, readable function, but it's very explicit.
I have a question.
Yep.
You know how you're using decimals for your power there?
Yep.
For the conversion to what? If this is an LSP7 NFT contract, wouldn't decimal be 1 or 0?
So if that's a great question. So if the contract is an NFT, meaning that here it's true, so like name, symbol, contract, owner, token type is non-divisible. Yeah, so if the contract is non-divisible here, meaning that you cannot split like a token in multiple parts, then you don't use the decimal at all. The decimal will be 0. So if you look at the source code on the right, if we go into the decimal function, it says that if it's non-divisible, so like you have the ternary here, if it's non-divisible, then the decimal return is 0, otherwise it's 18. So like if it's non-divisible, you don't have to multiply to the power of.
Right, but it's fine, that's still correct, the amount is...
Yeah. Yeah. Like if you will do that, and you write that, you are basically minting 10,000 way equivalent. So you are not minting 10,000 full token. You are minting 0.00000 of it. So like it's basically it's not divisible. So like if you do if unit converter. So this line here, this line that you see here, what it's going to do is it's going to convert to that. Yeah. So like it's like if I will write that basically. Yeah.
But just that's
Yeah.
power 0.
Yeah. We could write a comment. Okay, cool. Okay, where are we? Yeah, and one extra thing about LSP7 as well, which is nice, is that and LSP8 is that there is only a single transfer function, unlike ERC20. So like in ERC20, if you want to transfer token as a holder, you do transfer to amount. If you want to transfer as an operator, you do transfer from. In LSP7, there is no such thing. It's like transfer and you say from, to amount, force, and the data. So like if I am an operator, I am the caller, I call the, let's say you, Daniel, I grant you, allow you to transfer 10,000 of my tokens. You call the function, and from you were gonna say Jean's address to Louis' address, amount like the amount, and then the rest of the parameter. So it's just easier to use.
Do you still have like allowance in a smart contract or not?
Yeah. So like I will say authorize operator. I will say. So this is how I will do it. I will call me. I will call authorize operator. I will say Daniel's address as an operator. I'll grant him access for like 1,000 token. Any notification data, so that I notify you, like via the hooks we saw previously. And then you come along, and if you want to transfer some of my token to Louis, you will say transfer. Where is it? Transfer. So you will say, you will call transfer, you will say from my address to Louis' address, amount 1,000 token, and then the force parameter. So you will still, and your allowance will, and then as soon as you have transfer, your allowance decrease. Does that make sense?
Yep.
Yeah?
I mean, it's similar as normal ERC20.
Yeah. But the only difference is that it's just a single function. With ERC20, you will do transfer from. With and me as a token holder, I will do transfer. But here you just have one single function. And the operator is technically the from parameter. Does that make sense? Yeah.
But doesn't that like increase the gas usage if you have only one function and it has like two different threads?
Not really, because like if you have two public functions, you like what happened is that the like when in the generated bytecode you have like more selectors. So like the EVM has to search for the selector, like to say okay which function you are trying to run. So like here you are technically one less selector, but it doesn't increase that much. It's just going to unpack all the parameter in the function body, and so it's not like no, it's not really. I mean, yeah, LSP7 are a bit more expensive in terms of gas, but the added gas cost, it's mainly not about this parameter. It's the fact that you have the external hook to notify. This is what, for instance, increase more the gas than an extra parameter in the function. And yeah, and same for the burn function, it's the same thing. In the burnable extension, it's burned from amount data. And yeah, and what we can even do, so here, I mean, here we wrote the function manually to just really learn by doing. So like you see, we wrote mint publicly, but technically what we could do is that we could even, we have like a, we have the extension which is here, LSP7 contract extension, no, preset, sorry. LSP7 mintable. We have exactly the like, we could inherit this preset and add it to inheritance, and we don't need this function. But we could do that actually. I will just do it. So I will do import LSP7 mintable from LUKSO LSP7 dash contract preset LSP7 mintable, and if you add that here, you can just delete this function, and you can delete LSP7 digital asset, and normally you should be, and here you just have to write LSP7 mintable, and you should be good. Okay, and I think for ERC20, this is done. Yeah, so like, yeah, I basically explained the, you know, like the extra feature as we go. As you can see, it's not like a huge amount of change technically, like at the code level.
Just like different syntax, right? But like under the hood, it's
Yeah, yeah. How did you find it? Do you have any question, anything?
The idea of like hooks.
Okay. What in particular? What is it that you?
I mean, just because you can like set custom rules for like receiving some specific tokens. So for example, like right now on other like EVM chains, somebody can send like any tokens or like an airdrop, and then you already have like tags, you know.
Yeah, exactly.
That.
Yeah,
And
yeah.
you can maybe send that you know you don't want to receive any tokens after some time.
Yeah, exactly. Yeah, and I even think. I did a long time ago, like a talk where you could, yeah, you see, like even if you go into the LUKSO playground, you will see examples of how you could set up this universal receiver like that. So like you could deploy your own universal receiver and register the token that you consider as spam. So like if you have a full list, you register all of them, and it will look into it. If its token is a spam, then it will just, you see like, it will just reject it. Spam prevention, cannot register, cannot receive blacklisted token. So yeah, that's exactly the kind of use case why we have these hooks.
And also just some other like example, you can also forward to other addresses.
Yeah,
So whenever
you can.
receive some asset, you can forward it to like your, I don't know, you might have a vault wallet,
Yeah.
you might have a trading wallet. And
So it can also work as like a payment splitter. Or
yeah,
something.
exactly. So maybe you want to just send, I don't know, your child some money or some savings or something.
Yeah.
You can like split it.
Yeah, so let's like basic example. So like Natasha owns like a Clonex. If you send like a new Clonex to her UP, she can say like, okay, take this Clonex and just put it into a specific vault because it's like a valuable, like a valuable one. Or like if you have a specific, yeah. No, but yeah, like you can specify a rule like that, yeah.
So I mean, in this case, it makes EOA similar to like smart contract accounts, right? Almost like multi-sigs, so with some functionalities, right?
Yeah. You can have these custom rules where you say like certain assets I want to hold them into my UP, certain assets I want to hold them in my vault, or certain assets I don't want to hold them. Yeah. Okay. Yeah. I mean, let's do now.
Just one question. Will you also show like metadata and deploying?
Yeah. I'm gonna show you that.
Quite nice to see that and how it fits in the project.
Yeah. Yeah, and I mean, it's either we do ERC721 to LSP8 if you want, or we do metadata and JavaScript, TypeScript code. So like, yeah, for ERC721 is basically, it's basically the same. I will just actually show the final code. I think it will be quicker. So like, yeah, that will be an ERC721 contract. This is how it will be. And with LSP8, the only difference is that it's the same. So we used, actually we need to use LSP8 mutable. Yeah, so that's the same. I don't think I'm gonna recode it again because it's a bit time consuming, but it's the same thing. It's a name, symbol, initial owner, the type of token. And here, any extra parameter that we have is the token ID format. And basically, with LFTs on LUKSO, you can say like you can represent the identifier for the token IDs in multiple ways. You can say it's a number that gets incremented, or it's a unique name, or it's like an address, like another smart contract. If you want each token ID to be advanced like NFTs, or unique identifier, if you want more randomized, or like let's say hash digest, like hash of a specific string. And yeah, I have illustration. So this is like each NFT is like a number. This is the token ID format number. Each token ID is like a hashed value, or each NFT is another contract. You can have different representation. So let's say if it's like if it's like I don't know, like a Platy or like a chill whale or like a crypto kitty or like a video game character, we can have like them as smart contracts that have their own metadata and can be extended. Does that make sense?
So would these be like sub-collections that have their own smart contracts, or like each single NFT would have their own separate smart contract?
Each single, here in this case, each single NFT will be its own smart contract. Yeah, but you could also have sub-collections, yeah. You can create sub-collections. And yeah, and the only thing that changed in the transfer function is that we don't transfer an amount, we just transfer the token ID of the NFT. And yeah, it's basically the same thing. The only difference is that it's just a single transfer function instead of having transfer from, safe transfer from, and safe transfer from with data. Any question on that? No, all good? So yeah, I mean, yeah, to conclude, yeah, as you can see, it's fairly straightforward. It's not like a huge step to refactor, like to start from ERC code base and to refactor into LSP. And yeah, that's a good approach to learn like the token standard on LUKSO is that you start with you refactor like that, and as you go, you learn the new specific features, like, for instance, the token type or the token ID type for LSP8, or if they are non-divisible, or like the force parameter for like safety transfer, or like the hooks, and yeah, I think now we're gonna have a break, and we can look at the other feature like more, and we're gonna do more TypeScript and ethers in the next one. And yeah, that's it for now. Thank you.